Hello. In this lecture, you will learn what to do with requirements and when to do it. Requirements engineering is one of the main activities developed by software architects. As you can see, and we are going to explain in detail, it involves 5 interwoven incremental and iterative sub-activities, plus a 6th complementary activity supporting the whole process. The specific role in charge of this activity is called requirements engineer. Besides the requirements engineer, the stakeholders, that is, the clients, must engage to assure we are developing the right system. Elicitation gathers and discovers requirements from stakeholders and other sources, such as laws or industrial standards. A variety of techniques can be used, such as interviews, workshops, document analysis, prototyping, and others. For example, you can use a user interface prototype to better capture the client's expectations. Elicitation is the first step of requirements development. Analysis tries to reach a deeper and more precise understanding of each requirement. If you have doubts, don't stop asking for clarification. It involves also classifying requirements according to their type: information requirements, operation requirements, interface requirements, quality and performance requirements, and so on. Analysis can provide a first approach to system decomposition too, by grouping together requirements that are functionally related. Specification involves representing and storing the collected knowledge about requirements in a persistent and well-organized fashion that facilitates effective communication and change management. So, don't expect in the 21st century that the requirements document will be printed on paper. The output is mainly a set of written requirements and diagrams suitable for comprehension, review, and use by their intended audiences, that is, stakeholders on the one side and designers on the other side. The task of specification will identify gaps to be clarified with further analysis and elicitation. Verification assures that the specified requirements are free from internal errors. This activity can be autonomously realized by requirements engineers without stakeholder involvement. The kinds of errors that can be detected and eliminated from requirements include formal and semi-formal errors. Formal errors appear when different requirements are contradictory, that is, they cannot be simultaneously satisfied. Semi-formal errors are some defects of correctness that are not strictly logic or formal. For example, grammar or vocabulary errors, that is, requirements that do not adopt a consistent domain vocabulary throughout the specification, using instead synonyms and inconsistent, vague, or ill-defined terms. For example, suppose a home automation system uses the terms area, zone, sector, and room without clearly defining them. Is an area the same as a zone? Is a sector composed of rooms? Or can a room be split in different sectors? And so on. Specification and verification are not sequential activities, as represented for simplicity in the figure. Instead, they are fully interwoven in the process of writing requirements. In some cases, verification may indirectly demand further analysis and elicitation too. Requirements verification must not be confused with system verification, which assures that the implemented system meets the specified requirements. This goal is usually achieved through systematic empirical tests performed by members of the development team. The tests are applied first to smaller implementation units and finally to the whole system, seeking to eliminate implementation defects, that is, a lack of correspondence between the system and its requirements. Requirements verification, instead, eliminates internal errors only. Validation assures that the specified requirements properly express stakeholders' needs. This task reviews the documented requirements, with the essential feedback of stakeholders to correct any problems before the development group accepts them. Non-validated requirements demand further elicitation, analysis, or specification. Requirements validation must be accomplished within the requirements engineering process before the requirement specification is delivered to the development group, in order to avoid wasting resources to implement an undesired system. Requirements validation requires stakeholders to check their needs have been correctly interpreted in the form of requirements. A system might function perfectly to accomplish an undesired task. For example, do you really want your automated illumination system to track your movements along your home, or do you only want it to operate according to a time schedule? Therefore, the direct involvement of stakeholders is crucial to requirements validation. Requirements validation comes after requirements verification, since stakeholder involvement is typically very expensive, and we want to avoid attempts to validate ill-formed requirements. Requirements validation assures only a correct interpretation by stakeholders, but not the absence of internal errors. The stakeholders might be contradictory themselves. Remember, identifying internal errors was the task of requirements verification. Again, requirements validation must not be confused with system validation, which assures that the implemented system, not the collected requirements, satisfies stakeholders' needs. The sixth supporting activity is management. Its purpose is to tackle the unavoidable fact of requirements change during projects. To achieve this, management defines successive baselines of approved requirements and evaluates proposals for change. An information structure that supports dependencies between requirements and implementation artifacts, as well as a good policy for the dissemination of information, is essential to ease change and avoid its negative impact on the project. Thank you.